Hello, Algebra 1 students. In this video, we're going to cover inequalities in their graphs, so chapter 3.1. By the end of the video, you should be able to write, graph, and identify solutions of inequalities. Okay, so what is an inequality? It's a mathematical sentence that uses an inequality symbol to compare the values of two expressions. Now remember, expressions can be a number, it could be a number with a variable, it could be separated by operations. We can use a number line to visualize the values that satisfy an inequality, such as here on this page. What I would like for you to do as a takeaway from this is notice that you see circles. Okay, if there's a closed circle, that just means that that number is included. You look here on the left, x is less than 3. The open circle is just telling you that 3 is not included in that solution. So x will not be equal to 3, but it'll be everything less than 3. Okay, and then likewise, if you have the line underneath, such as here, this one, that says that it's going to be included. So your circle is going to be closed, solid. So it says that the solution will be 0 and anything less than 0. Okay, so here, this is going to be on your guided notes. You can, if you want to use a guided notes, it's great. If not, this is something you probably want to write down. The key symbols in words, it's important that you know the symbol, their meaning, and the associated words as well. So let's get into it. Writing inequalities. So you're going to be given a verbal expression. What inequality represents a verbal expression? All real numbers, x is less than or equal to -7. So you want to break it down. You're going to want to make this an expression. So how do we do that? All real numbers x. Well, that just means x. Okay. Another key word is less than. You want to look on that chart. If you have the guided notes, it's right there. You'll notice that is less than or equal to, excuse me, we're going to use the symbol that is pointing to the left, and it's going to have the line underneath it. All right, and then the -7, self-explanatory. We could just put those together, and this is what we represent from the verbal expression. X is less than or equal to -7. Let's show more. What inequality represents the verbal expression? 6 less than a number k is greater than 13. This is a little bit different from the other one. Let's break it down. 6 less than a number k. Well, this is a little bit different. If you notice, less than and is less than, they have different meanings. For example, 6 less than k is actually k minus 6. Okay, this goes back from chapter 1. If you don't remember what the meanings are, you might want to review that. And then 6 is less than k is going to be represented with the inequality symbol. Okay, so we're going to want to make this look like k minus 6. You're probably wondering, well, why did we flip it? Why isn't it 6 minus k? That's because of the word less than. Anytime you have those words, you got to flip it. Okay, so is greater than. Again, looking at your chart, this just means it's going to be the greater than symbol. And then 13 is pretty obvious. We can go ahead and put these together so it looks like this. K minus 6 is greater than 13. Okay, you may want to pause the video right now and try the practice on evaluating an expression from words. Because right now we're going to evaluate and identify solutions. So we're going to be asked, is -3 a solution of 2x plus 3 greater than -3? Guys, all you got to do is just plug in the -3 where the x is. And then ask yourself, well, does 2 times -3 plus 1, is that greater than -3? So after you simplify this, 2 times -3 gives us a -6 plus 1. That'll give us a -5. We've got to subtract. Well, is -5 greater than -3? No, it is not. It is actually less than. So what this is saying is that -3 does not make the original inequality true, so -3 is not a solution. Try one more here. Consider the numbers -1, 0, 1, and 3, which are going to be solutions of 13 minus 7y is less than 6. So all we got to do, again, plug it in. I'm going to write the original expression. So we've got 13 minus 7y is less than or equal to 6. I'm just going to plug in -1. All right. Instead of y, it's now -1. Okay, now remember, this is where you're going to want to do your order of operations. So we're going to take 13, -7 times -1 is going to give us a +7, less than or equal to 6. 13 plus 7 is 20, less than 6. So that is not a true statement. Okay, we're going to put a little line through that. It's not. So therefore, -1 is not a solution. Let's try the next one. Let's figure out what 0 comes to. So let's just plug in 0. Okay, so 13 minus 0 less than 6. 13, is that less than 6? Well, no, again, that is not a true statement. Okay, how about 1? Okay, let's plug in 1 now. I'm going to come over here. 13 minus 7 times 1 less than or equal to 6. 13 minus 7 less than or equal to 6. 13 minus 7, that should give us a 6. Oh, look at this. This one actually is a true statement. So far, 1 is a solution. So we'll just put solution. Okay, and now let's try the last one, 3. I'm going to come over here. 13 minus 7 times 3 less than or equal to 6. 13 minus 21 less than or equal to 6. Well, this is going to give us what, a -8, less than or equal to 6. This is also a true statement. So 1 and 3 are both solutions to that expression. Okay, so the next thing we're going to do is graph an inequality. This whole time we've understood what each one of these symbols mean, but what if you are asked to graph something like this? 2 is greater than or equal to a. Okay, this is a little different because you're probably thinking to yourself, well, isn't it supposed to be the variable first? And it doesn't matter. You can rewrite it so it looks better or makes more sense. But if 2 is greater than or equal to a, then a must be less than or equal to 2, right? So we can write it like that, or we can write it like this. A is less than or equal to 2. Just makes it easier because when you go to graph this, you'll see what happens. So all this means is you're taking 2, right? 2 is going to be your solution. We're gonna draw a closed circle because of, now this is where you want to keep in mind. You got that line underneath the symbol tells you that it's included. Okay, so we're going to include the 2. We're going to put a closed circle on the 2, and then if you haven't guessed it, you're going to shade in all the numbers to the left of 2. You can test your solution as well. What do I mean by that? Go ahead and pick out any number. Let's go with -1. Any number that's been shaded. Let's just plug it into A and see if that comes out as true. -1, is it less than or equal to 2? Absolutely, that is a true statement, so we did this right. Okay, what is the graph of x is greater than -4? As you notice here, we've got our inequality symbol is just the greater than, it's pointing to the right, and there's no line under it. So this means that we're going to not include -4 as a solution, right? So we're going to have an open circle on the -4, and we're going to shade everything to the right. Okay, I want y'all to start thinking about these. What is the graph of -x is less than or equal to 5? You might be wondering, well, this looks familiar. You can't have a negative variable, and that is very true. So we need to fix that. So we're going to have to divide both sides by -1. By doing this, it's going to flip our inequality symbol. This is one of those rules. Anytime you have an inequality and you divide or you multiply by a negative number, you must always flip the symbol. Okay, so look what happens here. We have now negative x over negative 1 gives us a positive x. We flip our symbol, as opposed to being less than or equal to, it's now greater than or equal to negative 5. Okay, because we have an equal to, we know that we're going to have negative 5 as a solution, so we're going to draw a closed circle on the negative 5 and then shade all numbers to the right. So key takeaway, guys, make sure you write this down. When you divide or multiply by a negative number, you must always flip the inequality symbol. Okay, the last thing we're going to cover is writing an inequality from a graph. So what inequality represents this graph? So you just want to decipher what you're seeing here. So the first thing you want to do is look at the arrow to see whether the solution to your variable, and you can, now I'm going to tell you this, you can make up any variable you want. Will the solution be greater than or less than the endpoint? So if you notice, because our arrow is pointing to the right, this means all numbers greater than negative 1 are going to be the solutions. Okay, so I'm just going to use x. So x is greater than negative 1. But there's another bit of information here, if you notice. The negative 1 has a closed circle. So this means that that number, negative 1, is going to be included. So x is also going to be negative 1, and x is going to be greater than negative 1. So the two of them combined, this is what you get. X is greater than or equal to negative 1. Okay, last example. What inequality represents the graph? So again, you're going to want to decipher what you see here. So you want to look at your arrow, right? Right now, everything's shaded to the left. Okay, so this means all values of our variable are going to be less than. Well, less than what? Well, let's look where it is. So this circle, this open circle, is on the 4. So I'm going to put that here. That means that x is less than 4. Okay, it's an open circle. That means that x will never be 4, and it'll actually never be greater than 4. With that being said, you could actually write it like this. 4 is greater than x. Okay, so it just tells you that x will never be greater than 4. All right, well, that was the video. I hope you all enjoyed it and have a great day.